Good morning, Massimo.
Good morning, Andrea. How are you?
Well, thank you. Good morning
Good
to
morning.
our attendees.
Good morning, everyone, and thank you for your participation in this webinar. Webinar that GM International dedicates to safety relay in their application. Andrea, if you are agree, let's wait a few moments before starting our presentation to allow everyone to connect.
Sure. Just write an answer to an attendee, which is sending message. You can write your question anytime in the Q&A button. The chat box is disabled, so use your Q&A button, please. Anytime. We try to answer during the webinar the question.
That's correct.
Also, some questions have been stored in our. We have two presentations just to give you more ideas. We have two PowerPoint presentations for this webinar, and the questions are in the second one. So let's wait another few seconds and go on with the new ones.
Okay, while we wait a few moments, let me introduce today's topics that intends to provide a general overview into the world of SIF certified safety relays, always widely used in the process automation application. Join me today, my colleague Andrea, that will help me to lead this meeting. Andrea, if you are agree, I think we can start now.
Yeah.
Well, let me give some information on today's speaker. As already mentioned, I have a pleasure to have him with me today, Andrea Spoller. Andrea is a global account manager at GM International. He has over 20 years of experience in the machine and process automation market. His main area of activity is in the industrial control process in hazardous area application involving signal conditioning, remote control, and bus interface. He has a great expertise in international relations in the automation sector and has consolidated his experience in Europe. Now he takes care of customer and market worldwide. Andrea is a functional safety engineer from 2016. And I, Massimo Pagani, I'm a product manager and technical support at GM International. I've been employee at GMI from about 10 years, and my main role is to receive and process customer technical requests and assist them in the correct choice of products to be used in their application. Furthermore, I collaborate with our research and development department for the implementations to promote GM products worldwide. I'm a functional safety engineer from 2020. Well, some words to introduce my company short. GM International is an Italian company born from the experience of an instrument, and for over 25 years has been design, engineer, and manufacturing a complete range of SIF certified intrinsic safe device. Our products are used in automation packages such as DCS, ESD, fire and gas, marine, and so on, in various industrial sectors such as oil and gas, petrochemical, pharmaceutical, food, and railway. All our products are tested one by one and must conform to the strictest worldwide specification. And in addition, all our products are entirely designed and produced in our headquarters in Italy. And last but not least, they are covered by 5 years warranty. In the next slide, they show how GMI is located around the world with over 200 people who make up our staff distributed on all continents. We have product stock distributed in our main branches in Dubai, Singapore, Houston, and other parts of the world. GMI has always been perceptive to market demands. For this reason, its products are innovative in order to get maximum customer satisfaction. The strong point on which GM International bases its activity is the complete pre- and post-sales assistance in order to lead its customer to find the best solution for their application and to assist them in the correct use of the products. In addition, all our products are intelligently designed and produced in our headquarters here in Italy and are tested in highly automated process. The goal of our company is to supply and guarantee innovative and high quality products. All our products are tested one by one and must conform to the strictest worldwide specification. Our products are tested and certified by over 15 independent TÜV agencies and laboratories, and they have certification available for different market applications: Europe, America, Korea, China, India, and so on. According to the new ESC 61500, the SIF certification of the products is no longer valid if not supported by the system capability design certification. For this reason, all our products are designed to adhere to the functional safety management SIL-free systematic capability certification. Additional, over 10% of GM employees are engaged in research and development of new technologies. Many of our resources are reinvested in the research and development department. In the next slide, you can see the wide range of products we deal with. Here we can see intrinsically safe barrier, safety relay, isolator, multiplexer, SIL-free power supply, termination board dedicated to the most popular PLC DCS system, R multiplexer, and so on. Furthermore, our company promotes advanced courses of functional safety and safety in AX environments conducted by expert trainers. You can find all the information about it in our website. The last slide lists some of our main collaborators and customers distributed among system vendor, EPC, O&M, and the end user. Well, but let's get to today's topic by introducing safety relays. Why it's important to use certified safety relay in safety application. Let's start by introducing the concept of SIS, Safety Instrumented System. SIS is a set of subsystems that make up the safety loop. Within this safety loop, we have field devices, such as transmitters or sensors, which allow us to control, detect, and measure variables in the field, such as temperature, pressure, or other. They are driven by barriers or isolators that provide for limiting the current towards the hazardous area or to isolate field instruments. And in turn, the signal sent by the field loop will be acquired, managed, and interpreted by what is the brain of the SIS or the PLC DCS system, which will decide on any action to be taken to make a plan to save. And again, power interfaces as can be a safety relay, which will then act on a valve and on an actuator, which allow us to bring the SIS in safety in case of need. The main concept that needs to be understood is that every single element of the SIS must be sized with a seal level, such as to allow us to obtain the overall seal of the SIS required. All components of a SIF, including power supply, to which we must be safety related and have a seal level. This helps us to have a safety loop and with the correct redundancy, a loop with high availability to the process. Well, Andrea, I think we have the first poll for our attendees at the now.
Oh yeah, you can, you want to have your opinion and your, let's say, vote on what you are using as a safety or type of relays. If you use just marshalling company relays with the no seal rating, if you use a seal relays with standard relays, or the last one is with the line and load monitoring. What type of relay do you use in your system? If you can take just 1 minute for answering, and we go on with the presentation. Okay, another few seconds and we stop the poll. Okay, thank you. I'm gonna close this poll. Okay, guys, thank you very much for answering, and thank you, Massimo, for this explanation. We have we want to give you an introduction, of course, of what is a safety relay. So anytime is required, the SIF is must conform to adhere to IEC 61508. Or in the typical cases when your controller is not able to give all the required power from the load, so you need an extra apparatus outside that is a relay. When of course you need to multiply the contact, you have just one contact out, just one DO, you wanna multiply this DO to different loads. Or you want, of course, inverter function. Your function is opening, you want to close when you open it, and vice versa, of course. That is a typical case for using a relay. But of course, a SIL certified relay is not only used in oil and gas, where of course GMI, petrochemical industry, where GMI is involved, but there are other industries like railways, car lift, power distribution. And I would say that anytime there is a failure relay can cause an accident. Okay, so if you use a standard relay that have a higher probability of failure, that can be the cause of an accident. Application where you're gonna use a safety relays are, of course, most of them are solenoid valve, SOV, for ESD or fire and gas applications. Other application is beacons, horn, and other signaling devices, BMS, power management system, or when you want to activate some motors, AC or DC motors. All relays are, of course, connected to a DCS PLC that, of course, is give you the permission of activate a load. But we're gonna have more details on that. So why you want to use a SIL? You're gonna use a SIL certified device because a standard relay cannot be used in a SIF. So if you use a standard relay with no SIL rating, that cannot be used as SIF. So your level of the loop that Massimo showed in the previous slides is gonna lose completely the SIL rating. So a SIL certified device is a relay that with a non-guaranteed ability to perform a given safety function. So this relay is certified that is able to perform a safety function. What is safety function? Safety function is the capability to reach safe states on demand. So you want to open a relief valve, for instance, or activate a fire extinguishing system. That is one of the applications that is where the safety lays is used. Most of the time, we can say that the safety function for ESD or IPS or BMS, safety function is normally energized. So in case of failure, you de-energize to safety, DTS. For fire and gas application, the safety function is opposite. So you want to energize in case of safety. So you move from normally de-energize, you want to energize, ETS, energize to safety. There are plenty of relays in the market, not only GMI, of course, that are offering ETS, energize to safety, or de-energize to safety, DTS relays. So the application can be very different, and the status of output is also different. But I want to just highlight the picture here where, for instance, very simple. I think you easily understand what I want to point out this point. So you have here a typical relay, our relays, for instance, that here in this case, for non-energized load, the relays are connected, you see, in series here. So typical application when the load is energized, you want to open and you need just one relay that opens for safety reasons the loop, and the loop will be disconnected. While for normally energized, you want to energize the load, okay, in case of safety. So the relays are connected here, you see the parallel. So serial connection for non-energized, a parallel connection to normally de-energized. Here again, some example. You have the coil from your card that energize our relays, okay, and the relays, the relays, and the load is normally energized. So in case of safety, so the safety function is open on demand. So de-energize the coil and the load open. So the load will be off. This is always the case where the coil is normally energized, but the load in this case is off. You see, contact is off. In case of failure, you wanna, of course, go to the safe state. Safe state meaning that you want to energize, in this case, one lamp. Okay. The other solution, the other possibility combination is where the coil is normally energized, the load is on, and in case of safe state, you wanna, of course, de-energize the load. Last case is, of course, the last one, when the coil is normally energized, you wanna energize the load. Those are all the possible combination you wanna have in a system. Well, of course, there is a solution on the market. I'm going to give you more details, for instance, that when the coil is normally energized, the load is normally energized as well. The first example I make on the previous slides. Here, one relay is suitable for SIL2 application. If you add another relay, okay, you're gonna have in series in this case, you see, because this is the relay. Okay. This is the I would say the load, the PLC, the card. So this is the relay. A relay with the 2 relays in series, you're gonna reach the SIL3 certification. While for normally energized, 1 relay is suitable for SIL1, 2 relays in parallel for SIL2, and 3 relays in parallel for SIL3. Okay. So this is a typical architecture where for having the SIL certification at the different level. So of course, SIL3 is much more safe than SIL1. For normally, I want to say also one thing which is very important is GMI is taking care of these specific features in parallel to the safety. We grant also availability. SIL, IEC 61508, 511 don't care about availability, but just care about safety. But also availability, I want to show you that is quite important. If you have this application, if you remember, this is SIL3 application for normally energized. One single failure, 1 relays, say you are in a safety situation where you don't want to open, but 1 relay open because by failure, because it's failing. In this case, I'm losing the power on my load, and I'm losing, I would say, my availability. Okay. In this case, I have a very high safety, but very low availability. Also in this case, which is, if you remember, the SIL3 for normally energized, the single failure relays can, of course, activate the load, and I'm losing as well availability. So high safety SIL3 for normally energized, but low availability with this architecture. I want to give you more details also about this point. So if you have, for instance, for normally energized load, you have the combination 1 out of 1, this combination. And here the architecture give you have a probability failure for safe failure, probability for dangerous failure. Well, the most important, of course, are the dangerous failure. But also the safe failure are important because you lose availability. So in architecture for non-energized 1 out of 1, mean time to failure in this architecture is 25 years. Okay. And dangerous failure is 50 years. So I'm very well about the safety, the dangerous failure parameter values, but not so good, of course, not perfect for safe failure. If I'm going to use the 1 out of 2, so always normal energized load, I have 2 relays in series, if you remember, okay? With this architecture, the safe failure are the less time. So I have the probability of failure that is double for say, because one relay can open without, without demand. But for dangerous failure, my dangerous failure are much more bad. So 2,500 years. This is of course, this application does not mean that relays last for 2,500 years. That is not, of course, not possible. But we say if you have a bench of relays, the probability for demand is that one. Okay, 2,500 years. If I'm using this architecture for normal energized load, I see that the safe failures is much more interesting values, but I reduce drastically what is the dangerous failure, because in case of dangerous failure, if one relay is not opening, the circuit remain closed, and I'm really in dangerous situation. This architecture, of course, is the 2 or 3 the voting. So the 2 are voting on deciding what is happening on the circuits, are very, let's say, very good value for safety, and for dangerous values, very good as well. So different architecture give you different parameters and different safe failure, dangerous values. Okay. Hope you are still there. I have another poll. So let me open this poll. Okay. So what kind of functionality for safety relays is very important for you? Like, of course, certification, CO3. The availability, demand availability, which is something that is, especially in the user, are demanding a lot. Availability, what is that? If one relay that, most of the time when you are using on the application, you don't know if you have normal energized upfront, of course. You don't know what, if you have normal energized load, then maybe you need just one relay that is suitable for both. Or you maybe want to have a multiple contacts relay. What is the most important feature you are asking? I just see that Massimo, people asking for more availability and safety. Okay, great.
Yeah, great.
That is something that we felt from the market. This need, of course, this need. Okay, I'm gonna close. Please answer if you're gonna answer. Otherwise, I'm gonna close this poll. Okay, thank you. Okay, still my turn, I guess. For a few other slides. Yeah. So safety and availability. What we did? Gemini did this kind of architecture for our relays, where we have 2 relays in parallel, and this series with the load and with the other 2 relays. So this is the architecture. Inside, this is the relay, okay? And for normally energized, what happens? It happens that in this case, I'm in condition where I'm safe. I don't want to open. Okay, I'm in safe condition. I'm not asking for open the circuits because I'm not in safety condition. So, sorry. One step back. I'm in safety condition. I want to open. Okay, and all the relay open except one stuck. Okay, so my circuit is open because these two relays are opening the circuits, but and I'm able to open if one relay is failing. Okay, so I'm safe with the one failure. Okay, for normally energized. But this architecture is also good for normally energized because I'm in a normally energized application and wait, I want to close my circuit. The one relay does not close, but I'm able to close the circuit because I have this relay that is closing the circuit. So also in this case, I have higher, let's say, safety because this architecture, one single relay failure is not affecting the safety function. So both for normally energized or normally energized application, my circuit is safe, even if I have one single failure relay. Okay? But this is also interesting for availability because I've seen that you answer in the poll that availability is very important. So for normal energy application, I'm in a situation where I don't need, in this case, safety, okay? I don't need to open circuit because my safety is good. I'm not in dangerous condition. So I wanna, say, stay in that condition, but one single relay is failing as last time is opening by accident. But I'm not losing availability because my load is still closed by these two circuits, okay, for normally energized. The same is very important is for normally energized. So if one relay closed without demand, okay, I'm not closing the circuit because this circuit is open here. Huh? So also for normally energized, I'm granting high availability. So in both cases, this architecture grants high safety and high availability as well. Hope this is clear to you. Don't know if you have any questions, just write us. Okay. So Massimo, I think it's your turn now.
Yes, thank you, Andrea, for your great explanation. And now let's move on the category of smart relay, or those relays that have the ability to perform diagnostic on the line and the load associated with them. These relays have the ability to extend the diagnostic of digital output card up to the load. The diagnostic of these relays are active both with energized relay and with the de-energized relay, and they can diagnose line opening, load short circuit, load earth leakage resistant, and for the more advanced model, also a possibility internal fault. But why going for smart relays? Nowadays, full diagnostic is typically required along the full loop. However, many widespread systems do not support diagnostic inside the digital output card. Smart relay made diagnostic available to systems that not support it. In other cases, many modern systems do not support digital output diagnostic. However, in many applications, they cannot directly drive the load because they are voltage and current limited, typically no more than 500 milliamp at 24 volt DC. Or again, when the load, valve, beacon, sounder, and so on, require more than 24 volt and or more than 500 milliamp, relay are necessary. Yet, when using standard relay, the digital output diagnostic dies at the relay coils and cannot reach the load in the field. As opposed to that, smart relays can go beyond the typical voltage current system limitation while keeping the full load diagnostic. Even if modern systems can perform load diagnostic, their capabilities may be limited. For instance, air leakage monitor may not be supported, or extreme load, for example, beacons, may always be reported as an open circuit to the system. Smart Relay may offer a solution to extend the digital output diagnostic capability. Well, conclusion on what we have seen so far. Let's summarize for our guests what we have discussed and why it's important to you. One, safety relay and derivatives, for example, Smart Relay, ensure and guarantee the safety of our critical loops, maintaining an high sea level, and allow us to extend the diagnostic capacity of our safety system across the entire loop. Point two, safety relay ensure high process availability and prevent spurious trips. This is very important and is a key factor for industrial process control. Three, these devices are supported by a project architect to certify and guaranteed by SIL certification, which provides the entire critical loop with a high guarantee of operation. And again, point four, all in one. This means that some of these modules allow us to have the solution to meet all types of application, ESD and fire and gas, in a single product. This guarantees a drastic reduction in cost and standardization of the products. And the last point, the onboard diagnostics of these devices and the compatibility with the pulse test function of the safety system on the market today are a fundamental requirement for these products. These fundamental characteristics allow us to carry out predictive diagnostic along the entire critical safety loop, guarantee an high quality standard of safety. Well, Andrea, we can conclude our...
Thank you. No question from your side? I don't think so.
No,
so
question.
Far. Let me close this presentation. As I say, that this is one part. There is a second part with your question that you made during your registration time. Let me check.
Yes, we can open the second part of our meeting. In this second part, we show which are the typical requests that most frequently are asked to us on the relay topic.
Can you see Massimo?
Yeah.
Okay. Okay. So some question. If you have others, just write us during and we answer or we try. So safety relay installation of Zardusar, because we are experts as Zardusar, but we didn't not mention this point. What is, of course, safety relay is current and that are required in this case are very high, so maybe for intrinsic safety, of course, they are not suitable. But of course, we can say something about our relays, Massimo.
Yes, it's possible to install a device, a safety relay, in the hazardous area, placing it in a special enclosure certified for the installation in this particular area. Or, are shown in the slide, in more cases, there are safety relays certified for installation in a hazardous area, especially suitable and certified for installation in zone 2. This allows us to install the relay as close as possible to the load, with great advantages in save cable or other installation feature. This means save a lot of cost.
Okay, thank you, Massimo. So other things in the past testing compatibility, what is this?
Okay, but before, what is the pulse test function in a PLC or in our safety system? Quite simple. It's the system with which the PLC checks the quality of the line that connects the output of the digital output card with the relay coil. This functionality is nowadays used by most of the safety system, but if the front end of the relay is not compatible with this function, it's possible to have chatter problem or even the relay failure, as the continuous open and close of the contact due to at the test pulse, it brings the relay to a premature end of line. This feature is important as it allows us to avoid damage to the relay contact due to chattering caused by the pulse test system. It allows us to avoid spurious activation of the load, always due to this line monitoring system acting on the safety system. The pulse test is usually active both when the digital output is on and when it's off. And these pulses can typically be harmful to the relay or to the application in general, causing malfunction of the relay itself or false switching of the SIF. It is important that the front end of our relay or our safety relay is specially designed to be compatible with this impulse and avoid possible problems caused by them. I want to underline that all safety and smart relay from GMI is compatible with this special function of the safety system.
Okay, great, Massimo. So is there any solution offering multiple contact output, so relays with the multiple contact output? This is the question.
Yes, there are solutions that provide for multiple output contacts controlled by a single input. This multiple output allows us to have multiple loads connected and driven simultaneously. For example, as in the slide, the model of D5290S078, this allows us to drive at least 2 seal loads with only one relay. In fact, this type of relay allows us to have application in which we can simultaneously drive 2 normally energized seal-free loads or 4 seal-2 loads, always normally energized or even 2 normally de-energized seal-free loads. Of course, the possibility of having different loads driven by a single relay allows us a considerable saving in terms of space, as in only 22 millimeters, we have the ability to control different applications.
Massimo, we have a few questions.
Yeah.
If you can read it, maybe we can answer. I think the second one is regarding the line monitoring, the load monitoring that is explained in the next slides. So the second one, we can skip it for the moment. You can take the first one, which is can wire connection looseness cause any failure to the relays? Can we see something to this?
The failure of the relay? No. I think no. My answer is no, because if the contact of the relay is as a problem.
So the question is, can wire connection looseness cause any failure to the relays?
Yeah, but you suppose that we lose the connection, or we have a connection on a terminal of the relay that is connected or disconnected. For example, I imagine the load supply. We can have a continuous power supply that is connected or or disconnected to our contact. In this case, it's important to have a protection on the contact side that allow us to avoid the possible damages in contacts inside the safety relay. This is my two.
Okay, great. So the second one is for the load monitoring. We have slides on this, so we can skip it for the moment. You will see on the next slides the answer.
Yeah. Okay.
Okay. So unipolar or bipolar wires load? This is another great question, because a lot of times we are facing with this way. You have a load which is meters, maybe 100 meters away from the cabinet. How can you connect in unipolar to save in wiring, or you need to connect as well in bipolar? So Massimo, let's try to answer this question.
Yes, the safety relay can be connected in both modes, in unipolar or bipolar configuration. A bipolar connection allows us to completely isolate the load, and this is recommended, especially in application where the load must be powered with high voltage. From an electrical point of view, this type of connection gives us greater safety thanks to the complete isolation of the load.
So
instead,
the relay, the load can be powered from 24 watt to 230, so no limitation.
Absolutely.
Okay.
Yes. Instead, a unipolar connection isolates the load only on one of the power supply lines, and allows us to bring negative to earth in case of need. Furthermore, this type of connection allows us great benefits from the point of view of the cable saving. This is the two mainly different between the two types of connection. Saving cost for unipolar wiring, but against the complete isolating of the load with the bipolar wiring.
Okay, Massimo, now it's me. I have a question for you. Is there any, say, we have talked about line monitoring. Is there any solution for having the line monitoring also? Because bipolar, I think, is quite standard on our relays. But is there any solution for having the line monitoring also on a unipolar connection?
Yes, we have a special safety. The special smart relay for this kind of request.
Okay.
Is a relay that is completely and total have a total configurable diagnostic that allows us to set this particular diagnostic also for unipolar connection. Of course,
okay.
Of course, the diagnostic in this case is have a reduction in the capability. Is limited, okay. But it's possible to have it also for this kind of connection.
Okay, great, thank you. So let's go ahead. So how do you choose a relay? A lot of times we have, because standard battery is analog, signal, digital, so it's quite simple. But a relay sometimes is quite complicated. So how can you choose a relay, Mass?
Okay, the choice of the correct safety relay must be made taking into consideration various factors, such as compatibility with the PLC pulse test system, the type of coil power supply, the safety function that it must perform. In this regard, it's important to say that the choice of the relay is fundamental relative to the type of load and the safety function it must perform. In fact, it would be very harmful to choose a relay, safety relay that performs a safety function different from the one required by the application we have to create. Supposed to choose a safety relay suitable for normally energized load to drive and fire and gas system. This will greatly increase the risk for our system. as using a wrong relay in its safety function increase the chance of failure in case of a relay intervention request. Therefore, it's important to choose the relay correctly based on the safety function it will have to perform. Furthermore, let us not forget that the choice must also be made, bearing in mind that the need for a diagnostic capability on the part of our relay, the need for single contacts or multiple contacts, and finally, the contact rate of the relay. Even in the latter case, the choice is important, as choosing an incorrect contact rating can have serious consequences for the state of health of the relay and therefore or the entire application.
Massimo, what about the power load, the voltage load, no limitation on this, I guess. Relays are standard. If you have people asking for 24 volt, 48 volt, or 110 volt DC, what can we say in this case for the load?
That is very important to protect the contact, because we can have a different power supply load, 24 volt AC or DC, or up to 250 volt DC or AC.
Okay, so you talk about the protection for the load. Okay, the protection we understand it is different, but we don't care about the power supply, the voltage power supply, because our relays are universal, you want to say.
Yeah.
Okay, great. Let me see if we have a question from one NTD. Overcurrent continues from PLC and DCS side to the relay can cause relay failure or short circuit to the whole loop. Overcurrent. How the relay will react to this case?
Okay, let me.
Right. Yeah.
But in this case, we have inside the our safety rear some protection.
The coil in the coil circuit.
In the coil circuit, we have a lot of protection. We have diodes. We have current limitation that protect in this case the coil of the relay. Okay,
in case of overcurrent. Okay, great.
Yeah.
Okay, so
at this slide, we say from this slide, GMI offer a wide choice of relay with possible coil power supply at different voltages. As I showed the slide, we have a relay for 24 volt DC, 48 volt DC, and so on. And the cotton rating ranking from 3 ampere up to 10 ampere in 22 millimeters. This is
okay. I want to say just something, which is customer asking more and more for DC load. DC load is something critical, and you cannot refer to such a level of current, I guess, Massimo, right?
Yeah, right.
Limitation this. So this is only
we must consider the rating of the current that circulates in the contacts when use the power supply in direct current.
DC. Okay, great. So you have this one. Can the fault for a monitor be remirrored directly to the PLCDO? So can the fault for a monitor relay? How we monitor it? And maybe this is also a probably question, okay?
Massimo? Yes. There are relays that when they detect a fault in the field, can, through a variation of the dynamic impedance of its input, send a fault signal to the most modern supervised PLC DCS system. This function allows us to reflect information relating to the field fault directly to to the supervised digital output card of our safety system, both in off state through the pulse test system and in on state by reading the static return of current. The digital output card of the PLC system can detect the information related to the field fault. This system, through an upward impedance variation of the relay input circuit, allows the supervised digital output to see the fault in the field. This system allows considerable safety engineering cost, as it allows us not to use a dedicated digital input card for this purpose.
Okay, Massimo. What kind of fault can you mirror to the system DO? What type of fault we can detect?
Of course, the open line circuit. This means when we cut the line that connect the load with the contact of the relay, or again we can diagnostic the short circuit of the load. This meter is supposed to have the valve in the field. We can detect with our smart relay the short circuit of the coil of the valve. And again, our smart relay can detect the loss of the power supply of the load. And in some cases, we can detect the leakage resistance that can create between the load and the earth. And for our top smart relay, we have the possibility to detect also the internal failure of the coil of the electromechanical relay that compose the matrix of the contacts inside our smart relay. This is the situation regarding the diagnostic on board of our smart relay.
Okay. Okay, great.
Okay.
Yeah.
Okay,
is
now,
my turn answering?
yes,
now,
yes, some question for you. Starting from this, a seal-free relay can be used in a seal-2 application.
I think we have also this one, Massimo, probably.
Oh.
The question was different, probably. Sorry for this interruption.
Okay, I jump to the next.
Yeah. Okay.
Okay. We have another question for me.
Yeah. Can the fault for a monitor relay be interfaced with the field bus? So the fault we've seen so far is mirrored to the system DO, but there are other solutions in the market.
Yeah. There are particular safety relay models called smart relay, which can provide complete diagnostic information, but through Modbus multi-drop RS485 protocol. If a Modbus master is available on the system side. Up to 127 modules can be arranged in a multi-drop network and monitored or configured by a single master unit, as shown in the picture. Each slave contains a table of parameters. Each of them is unequivocally identified through an address, and when requested, makes available its value for reading or writing. But what are the advantages of using Modbus communication? With a single Modbus RS485 interface, it's possible to connect and communicate with all the relay present on the same bus. Multi-drop connection is possible, and communication can cover a distance of up to 1,200 meters. And another advantage is the possibility of not using a dedicated digital input system to monitor alarm from our safety relay on the bus. This allows us to have significant savings in terms of cost, And again, real-time information, the type of alarms, and on the health of the load and the line is possible. It's also possible through Modbus. And again, a complete remote programming of the relay. This is the advantages that we can have with the Modbus on board of our smart relay.
Yeah, just me remind you that this, of course, if you use the mirroring as in the previous slide, the mirroring functionality, so the system DO will get an alert in case of fault. The Modbus give you some additional advantage because you know exactly what kind of fault.
Yes.
With the mirroring, you know just that is a generic fault, but in this case, through the Modbus register, you can get the real information about the fault.
Yes. We can understand if in the field we have a short circuit of the load, for example, or on open circuit, or if we lost the power supply of the load, and so on.
Yeah. Okay, let's go on.
Now is your turn. We back to the question before. A SIL-free relay can be used in a SIL-2 application, Andrea.
Okay, so we have seen that so far that the SIL can be to SIL-3 or SIL-4, but SIL-4 is not really using, it's not available in the use and not using the process application. Of course, the SIL-3 relay can be used in SIL-2 application, but not the SIL-2 relay in the SIL-3. You cannot increase the unless maybe you use a redundant system, but the single relays must be suitable for the SIF you need. And this is the first rule. There is also this graphic that show you how it works for in the system. So you have a situation where you have installed today a SIL-3 relay, and by the time maybe 1 year, 2 years, 3 years, depending on the hardware you're using, it goes, of course, is not longer safe. Maybe safe as it was, SIL-3 now, it goes to SIL-2 and maybe to SIL-1. So you are maybe a situation where you need to retest, to make a test proof for your hardware, to get the hardware as it was new to a situation where you, let's say, restore the initial situation in SIL-3 values. So you have to test the device for, and the test is provided by the manufacturer, what kind of test, but you need to test to restore the initial situation. So there is all hardware must be tested. Of course, there are hardware that must be tested more frequent than other, but all must be tested. We can also say that SIL-3 gives you a great advantage if you use a SIL-2 application, because a SIL-3 for 1 year, the example, could become SIL-2 for 10 years. So it means that you can use in the SIL-2 for 10 years without doing any test, unless you need this one for SIL-3, where you need 1 year testing. So the probability for demand, we say that degrades by the time. So will be worse by the time because hardware degrades. It's not more new. Okay.
Okay, thank you, Andrea. Another question relating to some aspect design on our safety relay.
So there are a lot of situations, a lot of aspects. For instance, of course, architecture that we have seen that this architecture or other architecture increases the cell level of the hardware. So we are talking with the inner relay inside one relay. Okay, so we have more relays that grant a SIL-3, SIL-2, SIL-3 function. Same way is also used for components inside. Okay, so resistance, capacitor, whatever is necessary that increase the safety values. Also, in this case, I think you heard about the beta factor. The beta factor is something very important because if you use the same component for redundant application, the same product component from the same manufacturer, from the same batch, there is a beta factor. Beta factor means that those hardware can fail with high probability at the same time. So you are not longer safe. So basically, it's very important to use two components for redundant function from different manufacturers or from different technologies to grant the safety. And also there are, of course, architecture that grant, as we have seen, safety and availability. So there are a lot of particular things that grants that make safe a relay. So there is a SIF safe value function. So there are components that with this parameter, which is getting higher, and you get, of course, higher the cell level. In this case, if you have, for instance, CL1 with the SIF 60%, with hardware fault tolerance on 0, can be used on a single application. While if you have more fault tolerance, you can higher the cell level. Of course, other parameters like gold plating contact, serial relay, forced contact, single multiple internal contact, whatever is important for granting the safety of serial relay or other hardware. FMEDA analysis, very important because FMEDA complete for relays, the FMEDA addition of all the components inside. If we are using, for instance, with a product or components with a higher temperature rates. Additionally, there are the safe failure and the dangerous failure, which are declared for every single components we are using in the hardware. And we have talked about a safe, dangerous failure. So Massimo, we can.
Yeah, Andrea, always relating also for what concerning the seal certification. What is the difference between safe and dangerous failures?
We have seen a little bit before this point, but here there is an example. I think all of you are familiar with this one. With this, you have a 4 to 20 milliamp signal standard, okay? That the range from 4 to 20 is this one, okay? So, and it can be, we can have different failures, okay? Different failure, I call it safe detected, so are safe but detected, can be safe undetected, so are always safe but I cannot detect, I cannot see, okay? Then there is a dangerous, which are very important, but I can detect. If it's dangerous and detected, it's okay. Most, of course, important and dangerous are those undetected. So there are those dangerous and undetected. So looking at a 4 to 20 milliamp signal, I can see that a small 2% variation in the range, I cannot detect it. I cannot detect it. That is maybe there is a failure, but of course it's safe because only 2% is not changing too much my process. What is dangerous? It's dangerous when this variation is within the limit of 4 to 20. For me, is a standard signal, is something that I can see that is a normal value, but maybe it's not normal, okay? Because maybe is temperature is low, but I see that that is going up, is going up to a certain level, but I'm not reacting, I'm not edging net. And in this case, we can say it is dangerous and undetected. Okay, so within the range with a big variation, but within the range of 4 to 20, this is called dangerous and undetected. Out of this range, of course, below 4 up to over 20, those can be safe or dangerous, but I can detect because I see that I'm out of the range. But in the range with the big variation, sometimes this is a big problem because I cannot, of course, really detect as dangerous. This is an example that you maybe much more idea about that.
Okay, thank you, Andrea. And something about a gold-plated contracts on the relay. Why it's important to have this
because
functionality?
Gold-plated grants the possibility of switching contact with if the current are lower than 100 milliamps. So maybe you have 5 amps relays and you use for small currents, and this create oxidation that can cause nuisance. It's a spurious trip, nuisance trips, whatever you call it, but are unwanted trips. And but the very important thing is if you use gold-plated, this you avoid this oxidation. You avoid this case for causing the spurious trip.
Okay.
So reliability for this current is 1 milliamp. So you can have also 1 milliamp, very small current, and you then don't cause any oxidation if you use a gold-plated.
Okay. And how is possible to have a SIL-free safety relay and the SIL2 diagnostic on board?
Okay, it's possible, Massimo, because there is a circuit. The diagnostic is a yellow, the circuit is a red, and the circuit is for SIL3 relay. Diagnostic is that one. Maybe diagnostic is because it's software-wise, it's very difficult to certify for SIL3. The thing is, the diagnosis is not interfering. It's certified for non-interfering with the safety function. Safety function is
a point.
What?
This is a point. It's not interfering. The diagnosis is not interfering.
The diagnosis is not interfering. So you grant your safety also in this case.
Okay, and the last question: differences between process and machine safety relays.
A lot of times we get a request for machine safety relays for applying that case, but we can't. The norm is a little bit different. So process application require the SIL certification, and the application are, as we see, valves, lights, sounders, whatever. And there is no manual control. This out, close, close, open, open. Nothing else. You cannot act on that. This is for the process. While on machines, the requirement for safety is different. Is PL, protection levels, called, and using safety gates, barriers, light grids, speed, standstill, whatever. And there is a manual control. There is a knowledge of the safety. So you can bypass, of course, assuring some safety, but the logic is completely different. So process, those relays can be used only for process application, not for safety. Okay, so let me close. Thank you. So we exceed 1 hour time. Thank you for staying there. We remind you that there are our webinars on our website. You can register for others or LinkedIn you if you are connected to GMI. I invite you to be connected to GMI. You can also see and watch again this webinar and the other on our YouTube channel. Just to go on our website, you can see this webinar. Questions? Just a comment. DC input normally uses 6-8 milliamp.
Yes, correct. If typically is the current when we use a digital input card, and for this reason, it's important to have a safety relay with a gold plate contact, because often we use this relay to put in communication one digital output card with the digital input card of another system, and the current is the current that is circulating in the contact is this 6-8 milliamp, and important to have a gold plate code to avoid the oxidation problem on the contacts.
Okay. Okay, thank you. We want to just have your vote on that, and don't worry, that's anonymous. You can write whatever you like. Hope you like it. We spend a lot of time and we try to share our experience on this. Don't hesitate to send us an email if you want to have more details, if you want to have more information about this topic, safety relays, smart relays, of course. Okay, thank you. I'm gonna close this poll. Thank you for answering, and we, of course, we just want to remind you our name, emails, and the face if you want to write us. Thank you, Massimo, for being here.
Thank you, Andrea, and thank you to all our attendees for the participation in our webinar.
Great, thank you.
Thank you. Bye-bye.
Keep
See you
safe.
next
Bye-bye.
time. Bye-bye.